welcome to all of you to this webinar. Today we have Dr. G. Nagendra Basu with us to deliver his speech in this webinar. So Dr. G. Nagendra Basu, he is currently working as an associate professor in the Department of Computer Science and Engineering, KSRM College of Engineering, Kadapa, Andhra Pradesh, and he has obtained his PhD in Computer Science and Engineering from Hindustan Institute of Technology and Science, deemed to be University Chennai. He has a teaching experience of over 16 years. He has been engaging classes for the undergraduate and postgraduate students. He has contributed extensively to the world of network security, wireless sensor network with very good publications. And today he will deliver on the topic that is overview of network security. So, sir, can here we can start with. Thank you.
Okay, madam. Thank you for my introduction. Good evening to HOD CSE, faculty members, and my dear students. Yeah, I already introduced by Mona Lisa, myself Nagendra Babu. Today I choose the topic overview of network security. Just a minute. My topic for today's session is overview of network security. Yeah, nowadays everybody is keeping their information either in individual or coming to organization level or at government level. Everyone, including all the organizations, are keeping information available over a computer networks. It becomes very immediate need for each individual and organization to secure their data as well as the services. So the network security should be aware of each and every person in day-to-day life at present. In my presentation, I would like to cover the following topics: what is computer security, CIA triad, security attacks, security mechanisms, research scope, finally virus and worm. First of all, I would like to introduce what is computer security. I hope all of you are aware of what is computer security, but coming to technical point of view, whatever the data as well as services that are required service, the major objectives for securing the data as well as services are confidentiality, integrity, and availability. National Institute of Standards and Technology, a technical promoting body from United States, have proposed this CIA triad, where C stands for confidentiality, I for integrity, A for availability. And this particular triad became a industrial international level security standard. Let's briefly discuss what is confidentiality. As we all know that confidentiality, we should not disclose our information to others. Okay, here also the same. Whatever the information we kept over the computer networks, that should be confidential from unauthorized individuals. Integrity. Integrity is also very important security concern. Nowadays, we are all exchanging information over networks, and we are expecting that that information is not altered while it is reaching to the receiver. So there should be need of integrity to assure the information what sender has sent exactly reaches to the receiver. And coming to availability, availability also very immediate need. If whatever the data services are not made available 24/7 basis at present, then it creates a serious problems to the stakeholders. And coming to security attack. What is a security attack? Any action that compromises the security of information owned by an individual or an organization, whether it is a confidentiality loss or integrity related security attack, or making unavailability of the services as well as data to the authorized users, any action relating to this, we can say that it is a security attack. There are so many classifications regarding security attacks, but one broad classification among the security attacks, they are, one is passive attack, another one is active attack. What is a passive attack? Here in passive attack, when you look at the image, when sender releases a message to the receiver, whether it is an email or a text message, whatever it is, sender expects confidentiality, but in the middle of the network, the attacker continuously listens to the communication channel and he gets the copy of the message. The attacker intention is just listening to the message, that's it. Attacker is not going to make any modification to the message. That's a kind of passive attack. Generally, coming to technical point of view, some of the attacks comes under this classification are release of message contents and traffic analysis. Let's come to active attack. An active attack attempts to alter the system resources or affect their operation. As we already discussed, in a passive attack, where attacker intention is just listening to the communication channel. Coming to the active attack, here, in addition to the listening to the communication channel and obtaining what message they are exchanging from sender to receiver, here the attacker is going to make some corrections to the message which is sending to the other end. Such a kind of attacks comes under the active attack. When you look at the message diagram here, while sender is sending the message, over a network, while it is traveling, the attacker is getting that message and he is going to modify the message. Okay, now what are the security mechanisms to prevent from security attacks? There are different kinds of attacks. As we already discussed as part of CIA triad, the major objectives for security of data as well as services are: one is confidentiality, integrity, and availability. Now we are going to focus in this presentation what are the security mechanisms to prevent attacks on confidentiality, integrity, as well as availability. Not only prevent, even if it is attack is occurred, how we are going to detect it, how we are going to recover from the attack. Encryption. This is also a very familiar term to all of us. Here, encryption can be defined as a way of scrambling data so that only authorized parties can understand the information. Here, in a understandable way, I can say, suppose you are encrypted the message, the original message is converted into not understandable format. Not understandable format at the sender side itself. Then that not understandable format message is transmitted over the computer network. Now you can assume if an attacker in the middle, he obtained the copy of message, he can't understand anything what sender is sending to the receiver. In such a manner, we are going to maintain confidentiality of the message that is transmitting over a network. Here also we have two types of encryption: symmetric encryption as well as asymmetric encryption. See, in order to convert the understandable message into not understandable format, we need to use a key as well as an algorithm. Here the key we use at the sender side for encrypting the message. Thereafter it is transmitted over the network At the receiver end, after receiving that not understandable message, here we call it as a ciphertext. The message the message which is actually being transmitted over a network is called as a plain text. Once it is converted into not understandable format, we can say it is a ciphertext by using some key as well as algorithm. Then it is transmitted over a network. At the receiver side, the ciphertext again is going to be decrypted into plain text. Here also we require a key as well as a algorithm. Here the algorithm is called as decryption algorithm at the receiver side. At the sender side, while you are encrypting, we can say that is the encryption algorithm. Both encryption as well as decryption algorithms make use of the same key in symmetric key encryption. And coming to asymmetric key encryption, it is also called as a public key encryption. Here, unlike symmetric key encryption, we use two different keys at sender side as well as receiver side. To encrypt the message, we use one key. To decrypt the message at the receiver side, we use a different key. For encryption, the key what we use is called as a public key. At the decryption end, the key we use for decrypting ciphertext into plain text is called as a private key. Then, what are the components of encryption process while you are encrypting? Generally, we require a plain text, the message to be transmitted, and it is going to be converted into not understandable format. We call it as a ciphertext. And key and algorithms for both encryption as well as decryption. These are the components of any encryption method. Let's see a simple example I have given here. Suppose the word zebra that need to be translated into ciphertext by using a simple algorithm, traditional encryption algorithm called as Caesar cipher. Suppose zebra, the first letter Z. Here the algorithm for encrypting plain text into ciphertext is C equal to P plus 3 mod 26, where P is going to be substituted with one letter from plain text at a time. One letter from plain text at a time. So here the plain text is zebra. Suppose we take Z first, then we convert into ciphertext. Then we take E, B or A. So after converting into ciphertext as per the encryption algorithm, the ciphertext will be CHEUD. This will be transmitted over the network. In the middle, if attacker gets that message, he cannot understand actually what sender is sending to the receiver. I hope you understood this algorithm mod operation. Suppose you take, I will discuss one or two letters. Z, first letter Z. Here all the alphabets are indexed from 1 to 26. The numbers 1 to 26. So Z is assigned with last 26. So when you encrypt the first letter of plain text Z, you are going to keep the value associated with Z is 26 in place of P in an encryption algorithm. So 26 plus 3, 29 mod 26. What is the result? 29 mod 26. In modulus operation, the remainder is the result. So 3 will be the result. Then what is the letter which is associated with 3 in alphabets starting from A1? C is the letter which is associated with the number 3. So Z is replaced by C. The same process is applied for remaining letters from the plain text. We can take one at a time and convert into plain text, ciphertext. Then the ciphertext is allowed to transmit over the network. Finally, at the receiver end, again we apply decryption algorithm where the input is a ciphertext and output is the plain text. Here we have decryption algorithm also, P equal to C minus 3 mod 26. And some of the encryption algorithms, here we have, in addition to Caesar cipher, data encryption standard, that is DES, IDEA, Blowfish, RC4. These are all comes under the symmetric key encryption, where we use the same key at the sender side as well as receiver side for encryption and as well as decryption. And coming to the example algorithms, comes under asymmetric encryption or public key encryption that includes RSA, Diffie-Hellman, ECC, elliptic curve cryptography, etc. All these either symmetric as well as asymmetric encryption algorithms are going to maintain the confidentiality of the message that is being transmitted over the network. So through encryption, we are going to preserve the confidentiality of the message which is being transmitted over the network. Then come to the next objective. The objective is, as per CIA triad, integrity. How to maintain integrity of the message that is being transmitted over the computer network. What is integrity? Again, recall. The sender expects the message which is actually he wants to transmit to the receiver should reach to the receiver as it is without any altering, without any changes. Here, the attackers in the middle, even though we apply the encryption, the ciphertext is transmitting over the communication channel. The attackers may try to get the copy of ciphertext. They are going to make changes to the ciphertext. Once it reaches to the receiver, the changed ciphertext is given as input to decryption algorithm, get some message, but that will be not plain text. So even though we have applied encryption method to preserve the confidentiality of the message, we are losing the integrity of the message. So in order to prevent the attacks on integrity of the message, one of the technique we have that is called as hashing. It is a technique or process of mapping keys, values into the hash table by using a hash function. Here we are not going to apply any algorithm on a plain text message, and we are not going to process the plain text. What the thing here we are going to do is, there are some hash values. By using hash function, the plain text is going to attached with randomly chosen hashes. When you look at the diagram, you may come to know, see, the keys means all the plain text. These are going to be associated with the hash codes by using a hash function. See, observe, randomly it is going to be associated. Even a multiple plain texts are associated with a single hash code. That permission is also there in case of hashing. And one more thing is, hash code for the size of plain text is variable, whereas the hash code will be same. Fixed length hash code is going to be associated for variable length of plain text messages. Examples for hashing techniques are the popular technique message digest, and the most secure hash algorithm till date SHA. Even SHA, see, 24 to 224, 256, 384, they're all the size of the hash code we get once you give the variable plain text. Message digest, it yields for any size of plain text, it yields only 128-bit hash code. Whereas coming to secure hash algorithm SHA, it is available in 4 versions: SHA 224, 256, 384, and 512. For a variable input, we will get fixed length output, that is hash code. In case of SHA 224, we get the hash code size of 224 bits. For 256, 256 bits, and so on. Likewise, RIPE-MD, Whirlpool, also popular hashing techniques for preserving the integrity of the message. And one more popular technique, we are all aware, digital signature. Digital signature also nothing but a hashing technique, but here we are going to say that it is a keyed hash function. A digital signature is a keyed hash function. What we are going to do here is, in addition to hashing, we are also going to apply encryption also. That is also, the encryption is also asymmetric key encryption we apply. So when you look at the diagram, The data that is to be transmitted first undergoes hashing function, then hash code is generated. For that hash code, a signature algorithm is applied with asymmetric encryption key. So here the private key is used for encryption. In case of digital signature method, we use private key of the signer to encrypt the message. Then the result, that is data as well as the signature obtained from signature algorithm, transmitted over the communication channel. At the receiver end, again, the data is given input for the hashing function. Some hash code is generated. Already here the signature is there, we have, that is encrypted. Again, that is decrypted by using verification algorithm. Here in verification algorithm, we use the public key of the signer. Then we get some hash code. The hash code which is obtained from this side as well as the hash code we get after data is given as input to the hashing function. If both are equal, then the message is accepted, or the receiver comes to know that the arrived message is from the exact sender, not from any intruder in the middle. For that purpose, we use the digital signature. Both comes under the hashing as well as digital signature. Both are the techniques for preserving the integrity of the message. Then come to availability. Another major objective of the security, that is high availability systems are the computing resources that have architectures that are specifically designed to improve availability when it is needed. Nowadays, making the data as well as services available to authorized users always is a major concern in case of the network security. We're all familiar with a popular kind of attack, DOS, denial of service attack, that comes under the category of availability. If any attack is on availability, making that the data or services or both are not made available to authorized users, then we can call it as a attack on availability. One such kind of attack is called as a denial of service. And the kind of things which comes under attacks on availability are hardware failures, upgrades or power outages. They needs to be improved. This is how we can provide the security for the data as well as services by keeping three objectives, major objectives in mind: confidentiality, integrity, as well as availability. We have seen what are the security mechanisms to preserve the confidentiality, that is encryption. Again, it is available in two flavors, symmetric as well as asymmetric encryption. Then to preserve the integrity, we have hashing digital signatures. And to preserve the availability of data as well as services, some of the things what we are going to have, some architectures we need to maintain to make the data as well as service available. And the research scope here in this context majorly is, nowadays cloud computing is becoming very popular. We are all keeping our data in cloud, not individual, even organizations data is also held at cloud. The cloud is being maintained by a third party. We should have confidence over the security of the data as well as services. So providing security in cloud computing is a challenge, still a challenge. So much research is going in this aspect. And some interesting research is going towards embedding artificial intelligence in security. And finally, security in IoT, Internet of Things. It became our daily routine. Most of the electronic gadgets comes under this category. Here also we require security. And coming to some more basic things here regarding network security, virus as well as worm. What is a virus? Computer virus is a kind of malicious computer program which, when executed, replicates itself and inserts its own code. Virus enters into a computer through a media and it comes into our systems and resides in some location. It will not replicate, it will not impact the system. Just it resides in a computer. When it starts, its impact is human intervention is required. When you open that file or when you execute that file with some human intervention, virus is going to be activated. From there, it is going to affect, it starts affecting our programs as well as data and services. Some of the popular viruses so far are Class, I Love You, WannaCry, GS, Code Red, and so on. And coming to worm, a computer worm is a type of malware. Unlike virus, worm when enters into the computer, it doesn't require any human intervention. Just it enters into the system through any kind of media. It starts replicating on its own, replicating number of copies into our system. Then it is going to impact the data as well as services that are present in our system. Some of the popular worms in this category are Nimda, Melissa, MS Blast, Sobig, Storm, Jerusalem. And what is a malware? Malware is a collection of viruses, worms, spyware, and adware. All this collection of malicious programs which are comes under the category called as a malware. The main thing we need to observe here between virus and worm, virus requires human intervention, whereas worm doesn't require any human intervention to start their impact. Okay, these are the major things we need to learn as part of network security. This will comes under the basics of the network security. As I said, the primary difference between virus and a worm is that virus must be triggered by an activation of their host, whereas worms are standalone malicious programs that can self-replicate and propagate independently. These are the differences. And any individual or organization, while they are maintaining data as well as services, they must keep three objectives in mainly, like confidentiality, integrity, and availability. And there are many methods are available in practice to preserve the confidentiality, integrity, and availability. But what are the basic methods, the traditional methods that I have explored in today's session, so that you can better understand this network security basics? Then you can go for further advanced topics. Thank you. This is
Thank
my
you, sir.
presentation.
Thank you, sir, for this wonderful session. Now I request to all the participants, they may ask if they have any queries. Okay, so I think anyone is not having any queries regarding the topic. Okay, so now I request to Bharat sir to convey his vote of thanks to sir.
Yeah, thank you, ma'am. Good afternoon, everyone. On behalf of the Department of Computer Science and Engineering, ITER Shiksha Mission University, I would like
Bharat
to
sir,
present.
Bharat sir, you are audible.
Hello, am I audible? Hello, hello, ma'am, am I audible?
Bharat Jyoti sir, are you there, sir? Okay, on behalf of Bharat Jyoti sir, I think he is having any audio issue. I thank to Dr. G. Nagendra Basu for for imparting such a valuable time, and the session was really very interesting. And it was we have sir has covered the very basics of the network security. Thank you, sir. Thank you for the presentation.
Okay, thank you, ma'am.
Thank you, sir.
Thank you
Now,
for having this opportunity.
Okay, thank you, sir. Actually, I got disconnected. Thank you very much for your time, sir. On behalf of this CSE department, we are really grateful for your time. And this webinar was really very simple and everything was quite clear. I hope the students will explore more on this. And with this, I would also like to thank everyone who participated in this webinar. And I also express my thanks to all the Museum team members and to the municipal again for coordinating this. Thank you.
so we may all leave now.